chemistry. First lesson in chemistry is acids and bases. So the first thing you need to know about acids and bases is pH, okay? Anything less than 7 is going to be acidic, anything greater than 7 is going to be basic, and 7 exactly is neutral. There's different ways to test the pH. You can test, all of these are called indicators, right? So indicators have different levels of preciseness. You can use litmus paper, which basically just says if it's an acid or a base. You can use pH paper, which isn't exact or precise, but it gives you a guesstimate of what the pH might be. You can use a pH scale, which is like exact, precise, whatever, or you can use organic indicators. Organic indicators would be like the ones that we prepared in class and did the lab report about. To prepare them, you need to boil it or grind it in the presence of alcohol. So an important thing to note about the difference between acids and bases is that acids, first of all, they're corrosive. If you put them onto metal or something like that, they'll burn them. They're also sour. An example of this is citrus. Lemon is sour, it's an acid. Bases, on the other hand, are bitter, and they're slippery. Good example of this, baking soda. So, this is an example of a pH paper. It would come with a key. So if the paper turns yellow, it would be the pH would be around 1 or 2. Similar to that. It's not exact, it's not precise, but it's a way to try and test. So there's the Arrhenius definition of acids, which basically says that an acid is a compound that dissociates or separates in water to give H3O plus ions, which could also be H plus ions. So you have an acid and it dissociates in water, it separates in water, and if it gives you have a compound, okay, it separates in water, it dissociates in water. If you get from that H3O plus ions or H plus ions, that means it's an acid. Oh, also, there's 2 types of acid reactions. A complete reaction would be where they separate completely. So you can see here, it's H3O plus, and then there's no H plus in this at all, right? Whereas the incomplete reaction, it's H3O plus and CH3COO minus. So see how there's still H3 in here? That means it's an incomplete reaction because there's still hydrogen in it after it separates into H3O plus ions. Now, the Arrhenius definition about bases is the same thing, except it gives OH minus ions. So you have a compound, it dissociates in water, it separates in water, you get OH minus ions. Same thing about complete and incomplete. If it's like Na plus and OH minus, that means it's incomplete because there's no hydrogen left in here. Or sorry, it's complete because there's no hydrogen left in here. It would be incomplete if there is still hydrogen in the proton. So this is called neutralization, where it becomes neutral because now there's no longer an acid or a base, right? It's now just water and something. So common neutralizations to know are HCl, NaO+, will give you this. So basically, if it ends up with water and something, it means it's a neutralization reaction. The product is neutral. This side of it is going to be neutral. So these are not to memorize, but they're kind of important to understand what happens. So pH indicators, organic pH indicators, will change color, whether it's neutral, acidic, or basic. Masalan, phenolphthalein, if it's acidic or neutral, it'll be colorless, but the moment it becomes a base, it'll be pink. This is what we use in titration, which I'll explain later. So, how do you know if it's a strong acid or a strong base? You see if it ionizes completely. Like I said, if there's still H+, if there's still H in the thing, like back here, it's going to be incomplete, which will make it a weak acid or a weak base. If it ionizes completely, it means it's a strong acid or a strong base. Okay, acids. I'm going to tell you guys a bit about the different reactions of acids. So acids, if they react with a metal, you will get every single time a salt and hydrogen gas. So if it's acid and metal, you're going to get some sort of salt and H2. Easy. Just, you have to memorize that because it'll come in handy later on. Acids and metal carbonates, when they react, this is called effervescence effect. You can see it right here, effervescence effect. An acid and a carbonate, when they react, will every single time give salt, water, and carbon dioxide. So something, H2O and CO2. And then acids and bases, like I said, I don't know if I said this, will give salt and water. You need to memorize these to some extent just because they're kind of important to know, and they will help you make sure that you're solving things correctly.